Hello everybody, Bradley Sward here, Day 7 solution for the 2024 Advent of Code. The problem's called bridge repair. I'm solving it as always, almost as always, in Python. Here is the problem. Basically, you have a list of numbers, and the number on the left is what number you need to be able to get to from either adding or multiplying all the numbers in a row one by one by one. There's no order of operations. You don't have to worry about the old PEMDAS rules. You just go left to right, multiplying, and if you can, and you have to try all the permutations of additions and multiplications, and if you can get one that ends up being the answer, well then, lo and behold, that's all good for you. So this is how I wrote the code. Let me run this because part 1 will get me an answer immediately, but part 2 will take a while because I don't have a very efficient way of doing it. But anyway, so what I'm doing here is I'm creating a list of all the permutations of all the different symbols, and we need to do this depending on the length of the numbers, the length of the list of numbers. We're going to have to do this all but one less time. So this will generate that for me. I just took this from Stack Overflow myself here, so I get what it does. I wouldn't have been able to figure it out on my own necessarily right now. But the file is open just the same. I strip out all the white space, and then on a line-by-line basis, I'm going ahead and figuring out what is the value I want, what is the list of numbers, and then here is my permutation list, and I'm trying every one of them, and I just need one of them to work out. Otherwise, I break out of the loop and I add to the total. But basically, all I'm doing is going, oh, you're going to add the first and the second numbers together, and then I'm going to, oh, you're going to subtract, you're going to multiply the next one and add and multiply, whatever the totals may be. And this is the code that will do this for each line, permutation for permutation. And when you get through this for loop, you'll be like, well, what is the value for this permutation? And if it equals what you're looking for, well, you found it. Pop it into the list and move on to the next. Otherwise, keep trying all the permutations. And when you try all the permutations for all the different lines and you run them together, I get this hugely large number that has 202 in the start and 321 at the back end. And there is that for this. So then for part 2, now there's a third operation. I thought they were going to make the PEMDAS rules apply where the multiplications had to come before that, but no. Now there's a concatenation operation, which means that now I can go ahead and concatenate the two strings together to form a new number. That in itself was actually pretty easy. Down part 2 here, you're just adding a third symbol. It doesn't have to be, it can be whatever I want it to be. But now this is a case, take the string of the original number, take the string of the other number, put them together, and then turn that into an integer. The reason why part 2 takes longer, or exponentially longer as it were, is because now we've gone from 2 to 3 different combinations. So like, basically let's just say there's 5 elements in here that we have to account for. Well, 2 to the 5th is 32, but 3 to the 5th power is like 729, I believe. And so like, as these numbers, as the length of numbers gets bigger, the amount of work I have to do to try to find one of these things is exponential. And I can see a few ways I could improve the algorithm, but I do get an answer in a semi-reasonable amount of time. One of you from yesterday said that my reasonable amount of time was not good enough and downvoted me. Shame on you. But come on, come at me today. Downvote me to hell. I don't care. But I have an answer. It'll come up when it comes up. It's going to be, when it comes up here, it's going to be this number that has a 159 in it, and then it's got a whatever. And I'm just going to sit here quietly until it gives you an answer. And then that will be the end of my video. So thanks for sticking it out with me as always. Hopefully see you guys in the next video. We'll see. Time is becoming short here in this time of year for me. So have a good one, everybody. Take it easy. We'll catch you then.